Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, good evening, everyone. Uh, in this session, we would like to present our material from our lecturer, Dr. Fajar, on about landfill design. This group consists of me, Lutfil Manfirdaus, Shifa, and Haikal. And the next slide, please. So this picture shows the landfill design of sanitary landfill method. Next, about landfill site requirements. In accordance with Indonesian National Standard 0334241 of 1994 on procedures for selecting landfill sites. Landfill are equipped with infrastructure and facilities consists of drainage infrastructure, road reception facility, waterproof layer, gas containment facility, leachate containment facility, cover material, heavy equipment, greening, and supporting facilities. And the next slide is the pictures of the sanitary landfill. Next. The landfill planning parameters. The first is the waste generations. The condition and factors that affect the amount of waste generation, such as economic level or income of the populations, the diversity of community activities, the living patterns or the habits, the physical characteristic and geography of the city, and also the climate and seasons, the development of packaging industry, and etc. The waste generation expressed in liters per person per day or kilogram per person per day. Next. The second aspect, parameters is land area requirement. It is the amount of land required will depend on the amount of waste to be disposed of. The larger the waste generated by a city, the wider the landfill needed to accommodate it. And in general, the determination of landfill needs of the waste generation is reduced. Initial density, the collected waste is transported to the landfill. At the landfill, the compaction process, and comparing the density of waste in the landfill and the initial condition, and then estimated the amount of landfill land needed. Next is the land area requirement and landfill capacity. The site used for the landfill should be able to accommodate waste disposal for a minimum of 5 years of operations. The initial calculation of landfill land requirement per year is as follows. This formula. The volume of waste to be disposed of times by the waste compaction level times by 365 divided with the height of the embankment is plain in meter, and then the land area requirement can be found with this formula, which is land area in a year times with the land age in a year times with the ratio of total land area to effective land area, basically usually 1.2. Next slide, please. Or the next is example. So we have to determine the landfill land requirement area for 5 years if it's known that the incoming waste every day is 800 meter cube with a planned pile height of 10 meters and a compaction factor of 0.33. How to solve it in the next slides. So we have to find the area land needed first. So the 356 days a year times with 800 meter cubic times with 5 year times with the compaction factor 0.3 divided with 10 meter, and then we will got around approximately 4.38 hectare, and the total area we will find with the the area of land that we have found, which is 43,800 meter square times with 1.2, and then we will got approximately 5.256 hectare. Next slide, please. So the next is landfill site planning. Um, things to be things to note is first the spatial suitability to avoid overlapping land uses. The second note is utilization plan. The utilization plan of the former landfill needs to be determined from the beginning. Some alternative of utilization of the former landfill, such such as greening, plantation land, parks or recreation areas, sport sites, and so on. And the third note is the disposal plan. By determining the type of the future landfill site utilizations, some landfill management plans can be adjusted to support the utilization plan. Something that need to be planned are utilization plan, compaction plan, closure plan, and provision of facilities. Next, the disposal method should meet this principle. The first is in large cities and metropolis, the sanitary landfill method is planned, while medium and small cities must at least plan for the control landfill method. There must be control of leachate, which is formed formed from the decomposition process of waste, so as not to pollute the soil, groundwater, and existing water bodies. There must be control of gases and odors from waste decompositions, so as not to pollute the air, cause fire or smoke hazard, and, cause the greenhouse effects. There must be control of disease factors. Next. Um, the landfill infrastructure and facilities planning. The public facilities consist of access road, operation roads, support buildings, drainage, fences, and signage. And the environmental protection facilities consist of landfill-based formations, leachate collection channels, gas fans, ground cover, buffer zone, and test well. Test wells. Uh, I think that's all from me. The next slide material will be presented by Shiva. To Shiva, time is yours.
Okay, for the next is the supporting facilities consists of weight bridge, clean water, hangar, firefighting facilities, and the recycling and composting facilities. For the operational facilities, consists of the operational facilities required are heavy equipment such as bulldozer, wheel or trucks loaders, excavator, or the backhoes. And for the next is the layout plan. In determining the layout plan for the sanitary landfill, we must consider the land use should be optimized so that the land uh, is no land is left unused, and the landfill site should be protected from public roads that pass through it. This can be done by placing a living fence around the landfill, which can also function as a buffer zone. And therefore, the leachate treatment ponds should be located so that leachate flows by gravity as much as possible. The placement of operational routes must be adjusted to the landfill cells or blocks so that all waste piles can be easily accessed by trucks and large equipment. This is the example of the layout plan for the sanitary landfill, and this is also the layout design for landfill. And what is the stage of landfill design? First is the pre-construction phase, consists of selection of landfill site and survey and field measurement, and then landfill design, land acquisition, and permit issuance, and then socialization. For the construction phase, including the mobilization of personnel and equipment, site clearance, construction of facilities, for the general environmental protection and for supporting facilities. And for the post-construction phase, consists of landfill operation and maintenance, reclamation of former landfill site, and post-operation landfill monitoring. And then the environmental assessment document in accordance with applicable laws and regulation. In Indonesia, we have Government Regulation number 22 of 2021 and Minister of Environment and Forestry Decree number 4 of 2021. And then we have Environmental Impact Assessment, or we call it AMDAL, for landfills more than 5,000 tons per day, or landfills located in tidal areas for all size. And also we have the UKLPL, or the environmental management efforts and environmental monitoring efforts for landfill less than 500 tons per day. And for the general provisions for landfill design, the selection of urban landfill sites must comply with existing regulation. The design of urban landfills must consider first the urban development plans, uh, land use, and plans for the utilization of former landfill sites are included in the RTRW, or the Regional Special Plan. And then the economic capacity of the local government and community to determine the technology, facilities, and infrastructure of landfills that are economically, technically, and environmentally feasible. And next is physical and geological conditions such as topography, soil type, soil permeability, groundwater depth, surrounding water condition, tidal influence, wind, climate, rainfall to determine the final waste disposal method. And then plans for the development of the existing road network to determine the access road for the landfill. And then the last is landfill plants in sloping areas, taking into account the possibility of landslide. And for operating and maintenance costs for landfill are available, and also the waste disposed of at the landfill must have undergone volume reduction or using the 3R program and composting at source. And then waste disposed of at the landfill site is limited to municipal waste that does not originate from industry of or the hazardous waste or hospitals, for example, infectious waste. And for cities that have difficulty securing landfill sites within their jurisdiction, a regional landfill model must be implemented. And for the next, back to the moderator.
Very well, thank you, Shifa. Next slide will be present with Haikal. To Haikal, the screen is yours.
All right, thank you, moderator. Okay, next slide is tell about the survey and field measurement of the landfill site. The required data is first amount of the waste to be disposed of at the landfill site, composition and characteristic of the waste, data and or road network to the landfill site, and the last one is number of transport vehicle or garbage truck. Next slide, please. Okay, next is field measurement. First is topography, also soil characteristic, include physical characteristic, which is soil composition, hydraulic conductivity, pH, and CIC. And chemical characteristic include soil mineral composition, anions, and cations. Next is founder and geophysics. Also, location of the spring, if any, including discharge. And the last one is groundwater condition, which is include depth of the groundwater table, groundwater flow direction, groundwater quality like COD, BOD, and heavy metal, chloride, Fe, and also organics. Next slide, please. Surface water condition like this distance from the landfill water level and its fluctuation in dry and rainy season. River water quality like COD, BID, heavy metal, and chloride and pesticide sulfate. Next is leachate quality. Include the COD, BOD, heavy metal, chloride, and organics. Next is the air quality, like level of CH4, COX, SOX, NOx, and etc. And the last one is number of people living around the landfill, with the radius is less than 500 meters. Next slide, please. Okay. This slide tell about detailing engineering design or DAD in the TP. Include the set plan design adapted to the available land condition, facility design like public, environmental protection, and support. Stage of development according to regional funding capabilities. And the last one is DAD document with detailed drawing, SOPs, tender document, technical specification, RAB, and etc. Next slide, please. Next slide. This slide tell about the TPA facilities and infrastructure. First is public facilities. Include public facilities, environmental protection facilities, support facilities, and also operational facilities. Next is the public facilities. Driveway include the driveway, office, grand guardhouse, workshop, garage, drainage channel, waste processing facilities like recycling, composting, incineration, fencing, and signage. Next is environmental protection facilities, include landfill-based impermeable layer, leachate collection with containment and treatment, gas ventilation for CH4, overburden like for daily, intermediate, and final, buffer zone to reduce the impact of the landfill, and the last one is monitoring well. Next slide, please. This is the root of the environmental protection facilities. It must include leachate collection, landfill waste, monitoring props, and some like gas flare, surface drainage, and gas well. The next, please. The last one is support facilities, include the weight bridge for waste more than 50 tons per day, clean water and wastewater facilities, fire extinguishers, electricity and communication device, fuel reserves, and insecticide reserve. Next slide, please. This slide is tell about the operational facilities, include the heavy equipment like bulldozer, excavators, landfill compactor, and loaders, earth moving truck like dump truck, and stock of the cover soil. Next slide, please. Okay, here are some picture of the heavy equipment is used that used. First is there is a bulldozer. Next is there is a wheel loader, excavator, and landfill compactor. Next slide, please. In this slide, it's all about the sanitary landfill management, and the landfill must be included with some facilities like landfill gas management, leachate management, landfill design, which include like some final cover design, surface water drainage, site planning, and gas collection system design. Mm. The landfill must have like pipe for CH4 and also for leachate. Next slide, please. Right. In this picture, there is an image of a sanitary landfill, which if we notice, there is a pipe to take leachate from the waste, named a leachate collection pipe, and also after that it process in the leachate retention pit. Okay. Okay, that's all from me. I yield back to the moderator.
All right, thank you very much. So now we will move into the questions and answer sessions. If you have any questions, please feel free to raise your hands. Arata, please go on.
Okay, thank you for the moderator and also the presenter as well from the group one. So my name is Arates Malfi from the group two. Would like to ask you some questions. So the first one that you already explained before in the example and also the solution. I think it might be on the ninth slide. Yeah. So in the total areas, it is shown that 43,800 square meter times by 1.20. I'm a bit confused with this numbers. Where does it comes from? And that is my first question. And for the second question of mine is how can landfill design and management strategies minimize the risk of environmental pollution when the floods is happening, because we know that we are in the disaster management course. So how can the design of the landfill itself can minimize the risk of environmental pollution such as the leachate during the flood events? Maybe that's all from me. Giving back to moderator.
All right, we got it. Thank you. So next to Agusti, uh, may I know
Okay.
your questions?
So first, my name is Rahmi with ID number 3006. I would like to ask some questions to Group 1. So the first question is, how should landfill design be adapted to withstand natural disaster such as earthquakes or the floods? And the second question is, how can monitoring systems be integrated into landfill design to provide early warning and response during disaster conditions? Thank you.
All right, we got it. Thank you. So now we will answer all of the questions. The first questions about how can landfill design and management strategies minimize the risk of environmental pollutions like leachate during floods. It will be answered with Haikal. To Haikal Tamishores.
All right, thank you, Lutfi. So the answer from the group one is first is to minimize environmental pollution risks such as leachate during extreme flooding. Landfill should be strategically site on elevated ground and designed with above grade structure. A robust leachate collecting system with backup pumps and composite liners help contain and manage leachate effectively. Protective feature like maybe like perimeter berms, storm water detention basin, and impermeable caps to reduce the flood infiltration. Emergency leachate storage and spill containment measure ensure the overflow is controlled. Regular maintenance and climate resilient upgrade support by updated risk assessment and landfill resilience against the future flooding event. I think that's my answer. Is that clear, Areta?
I actually didn't really got the point. Can you like concise it? What is the short answer, maybe?
All right. So to minimize the environmental pollution risk in like the leachate during extreme flooding, the landfill should be strategically sited on elevated ground and designed with above grade structure. So usually landfill a landfill site in at the height elevated, so it's have a low risk in flooding, thing like that. Is that clear, Areta?
Can I give a follow-up question?
Sure.
Okay, maybe for concise, I think in the picture of the 31 slide, it giving environmental protection facilities, and it has a leachate drainage in there. So even if during the flood it will be I don't know, maybe it will contaminate the flood will contaminate by the leachate itself, because we know that the leachate is isn't what is that um really managed that well. So what is the best solutions if you are as environmental engineering to manage this problem? Maybe I will write down the question again. Maybe you can answer another question first.
All right, Narada, thank you. We'll answer that soon.
All right, very well. Then I'm gonna answer Reta's second questions. First, I want to request to Shifa, can you help me to share screen the uh the 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 slide again, please? Um, the the slide number 9, please. Thank you. Slide number 9, please. So basically, Reta asking about where does 1.2 comes from in total area calculations. So basically, it is shown at the slide 7, the formula. The previous slide, please. The previous one again. So yeah, that's it. So the land area requirement, the 1.2 is the ratio of total land area to effective land area, and the ratio is 1.2. So I think this is where 1.2 comes from. Is it all good, Areta, or do you have any follow-up questions?
Okay, that's enough for me. Thank you.
Very well, thank you. So next we will move to Rami questions. Uh, she's asking about how can monitoring system can be integrated into landfill design to provide early warning and response during disaster conditions. And this question will be answered by Shifa. To Shifa, time is yours.
Okay, thank you, moderator. So for the question, how can monitoring system be integrated into landfill design to provide early warning and response during disaster condition? So we can imagine we are designing a landfill and want to make it super safe and prepared for anything that could go wrong, like disaster. We can do this by integrating a smart monitoring system into the design. This involves using sensors to keep tabs on things like leachate level or the gas emissions and the stability of the landfill structure. And then the data from these sensors is then fed into a central system that use model to evaluate the risks and forecast any potential issues like the diffusion of contaminants into the surrounding environment. If something does go wrong, like a power loss or a high liquid level, the system can send out alarms via text and even automatically active the controls to prevent bigger problems, like it can stopping the flow of liquids to prevent overflows. by using the unmanned aerial vehicles and long distance communication, it can help establish an integrated emergency environmental monitoring system. This way, we can catch problems early and respond quickly, protecting both the environment and the people working there. That's all from me. Back to the moderator.
Thank you so much, Shifa. So, Ami, do you have any follow-up question regarding Shifa's answers?
That's enough for me. Thank you.
All right, then I will answer another question from Ami. How should landfill design be adapted to withstand natural disasters such as earthquakes or floods? I think to withstand natural disasters such as earthquake or floods, landfill design must prioritize structural stability and throttle protections. For earthquake prone areas, the engineer should incorporate flexible geomembrane liners and seismic resistant designs, including reinforced slopes and retaining walls that can absorb or shift with ground movement. And in flood-prone regions, the landfill should be elevated above the expected flood levels and include robust stormwater management system like diversion channel and reinforced berms. And the landfill cover system should also be strengthened to prevent erosion and water infiltration during heavy rains or flooding events. I think that's all. So, to Ami, do you have any follow-up question regarding to my answers?
That's all good for me. Thank you for the group one.
All right, thank you so much. Then now we will back to the first Areta question that answered by Haikal. The Rita have a follow-up questions about how vulnerable is the leachate drainage system in sanitary landfills to backflow or overflow during flooding events, and it will be answer to Haikal again. To Haikal, uh, time is yours.
All right, I would like to answer the follow-up question from Arita. The answer is the leachate drainage system in sanitary landfill is vulnerable to backflow or overflow during flooding due to hydraulic overload. Stormwater infiltration, blocked or damaged pipe, and power failure affecting the plant. This condition can lead to extensive leachate accumulation and potential linear failure, and also increasing the risk of environmental contamination. All right, give back to moderator. Is that clear, Areta?
Okay, thank you, Haikal.
All right, I give